So we're looking at page 22 in the packet, Unit 2. This is related to sample space information, and so these are some popular sample spaces that come up repeatedly in probability. Not because they're particularly important concepts like, discussions of money or, games of chance or things like that. I mean, academically, I'm sure some people find games of chance to be very important concepts. But because they have known probabilities and they kind of lend themselves to the concepts that we're learning. So we kind of focus on these things. So you're going to look at page 22 as kind of a reference sheet if you don't know some of these facts. Like, for example, the deck of cards. People, when I first started teaching 20 plus years ago, everybody, some exceptions here and there, but almost everybody knew the structure of a deck of cards. Now it's a crapshoot as to whether or not people know that. It's also a crapshoot as to whether or not people know the origin of the term crapshoot. It's not as disgusting as it might seem. Right? It actually has has an origin in the game of craps, which is a dice-based game. Right? So I listed out the two sample spaces for dice, a single die and two dice, because those are reasonably sized. If we get into three dice, then it gets a little, off the wall. There's actually 216 outcomes in three rolls of a die or three dice, right? Or three dice. Yeah, exactly. Yeah. I even screwed myself up on the whole plural of die, right? So the singular for a die for a dice is die, which sounds horrible, but the plural for die is dice. All right, so there you go, if you didn't know. All right, so the breakdown of the deck of cards, those clover-looking things, if you don't know, those are called clubs. The diamonds are diamonds, the hearts are hearts. The upside-down heart with the stem on it, that's known as a spade. All right, we call the cards that actually have faces on them, you guessed it, we call those face cards. But some people call them picture cards. I don't particularly like using the term picture card, only because it's like, well, they all have pictures on them to some extent. Those are more like portraits, of the royal court. So anyway, that's the breakdown. Half the deck's black, half of it's red. The reason I have the prime numbers listed below is because sometimes questions will say, find the probability of getting a heart from a deck of cards that's also a prime number. In which case you'd look at it and say, oh, well, here's a prime, here's a prime, here's a prime, here's a prime. And so when you're looking at the possible outcomes, you have the whole sample space in front of you. You'd say, well, which ones are the relevant ones based off of the question? You'd say, I got this one, 2, 3, 4 out of the 52 available. All right, so if you have a sample space right in front of you, probability could be pretty easy. Sometimes you don't have the sample space in front of you, in which case we need to come up with those values ourselves. Right? Prime numbers, perfect numbers, all pretty important stuff. I gave a list of perfect numbers. The y equals notation, that's actually old school TI 84 stuff. If you're doing it on Desmos, if you want a list of perfect numbers, what you can do is just make a little table, put in the numbers starting it with 1, 2, and then, populate, let's say the first, I'll go to 15 values, and just take whatever that column heading is and raise that to the desired power.